All right, so I want to do version 1 of the final exam just to kind of work through some things and give you an idea of how all this stuff should work. So we want to know what's happening in this position versus time graph. So notice, first of all, since this is a position versus time graph, that must mean we're moving at a steady speed. And in this case, since the slope is negative, we're going backwards. And in this case, we're going, in the bottom, we're going forwards. And it looks like the slope has about the same value, meaning the slant's the same. So what that means is that they're moving in opposite directions at the same speed. Now here, in a position versus time graph, we are clearly moving backwards since the slope is negative. And the other thing is, since this is a linear plot, that means that we are moving at constant velocity. And we're starting at a forwards position away from the origin. So we start from a positive position and we're moving backwards at constant velocity. That's choice B. Now, what are we doing in this velocity versus time graph? Now, let's be careful. This is a velocity versus time graph. So what's happening here is that I actually have a backwards steady speed. Again, this is no longer a graph of where I am. It's a graph of how fast I'm going. So what that means is that I'm moving backwards at a constant velocity. Excellent. Now, question 4. We have this position versus time graph. We want to know how fast we're going. So since we want to know what the velocity of the object is, we need the slope. So I'm actually going to use this point here, which is 8 seconds at a position of 0. And the initial position is 0 seconds at a position of 200. And so when we get the slope, we're going to actually have y2 minus y1 over x2 minus x1. And when we simplify this, oh, you know what? I actually have it backwards. It's y2 minus y1 over x2 minus x1, and that's going to actually give us a slope of negative 25 centimeters per second, which is choice D. And here, what is the position of the object at 5 seconds? So we're simply going to read its position off the graph. So at 5 seconds, if this is 50 and this is 100, this has got to be 75 right there. So we're at 75 centimeters. And where will the object be after 30 seconds? Well, let's see if we can figure this out from the equation. So we've got x equals v naught t plus x naught. Let's remember this is the y-intercept, and this is the slope, and that's the intercept. So we know the position function is given by x equals negative 25 times t, because that's the slope that we got right here. And our starting position is here at 200. So we'll put plus 200 right there. So we want to know where we're going to be after 30 seconds. We plug in the number. X is negative 25 times 30 plus 200. And when we actually work that out, it's going to work out to be negative 550 centimeters. So in the next problem, we'll actually take a look at problems 7 through 14.